Hi everyone, welcome to lesson 4 today. We're going to be talking about inverse functions today. This is going to be our last lesson for transformations. Before we get into it, we have this opener question here. It says, describe how the graph of y equals radical x, square root x, basically compares to the graph of this one here. If the point 93 lies on the original, what's the new point on the transformed graph? So basically what we need to do is rewrite this equation so that we can pull out our mapping so that we can remap 9, 3. So very first thing to do, let's rewrite our equation. So the first thing I notice in our equation is I see y is not by itself there, so I'm going to try my best to isolate for y. So I'm going to start my equation off to the side here. Have y equals, moving that 1 to the other side, we have minus 2 radical, that 3, we don't have a dedicated b value as well, so I'm going to make a dedicated b value, so I'm going to have a 3 right there, bracket x, so 3 times x gets me back to 3x, and 3 times what would get me back to negative 9, that's going to be a negative 3. Close bracket, radical on top of that, moving this one over, plus 1. There we go, so we have our equation isolated, and that's what we need. We now need to figure out, well, what transformations do we have? Well, I'm seeing about 5 of them here. The very first one here is that negative sign. So we're reflecting it on the x-axis. So we definitely have a reflection. That 2 there, of course, that 2 outside of our function is a vertical stretch. We have a horizontal stretch, of course, that's what this 3 here is. That's a horizontal stretch. It looks like we have another right here, and that 3 there is a horizontal translation. And last but not least, we have a vertical translation with that 1 there, so that's a vertical translation. So with all that said, let's figure out our mapping. So we have x comma y, that's on the original, and when we map this to our new, we need all the horizontals together and all the verticals together. So horizontal translation, so that's going to be x plus 3, a horizontal stretch of 3, so that's now going to be 1/3. So from an x value, I have 1/3 x, because that's the horizontal stretch by 3, and horizontal translation minus 3 there, so that means we're going to really move 3 to the right. For my verticals, I have a reflection, so that's the very first one I have is a reflection over the x-axis, so that's a vertical reflection, so that's going to be minus 2y, and we have a vertical transformation, or translation, sorry, of up 1, so that's a plus 1. So this is my equation that I'm going to use here to help me map out 9, 3. So what do? I sub in the values of 9, 3. Sorry, that's a 9 and a 3 there. I sub in the values for 9, 3, and we're going to see what happens to 9, 3. So if I sub in 9 into this equation here, I got 9 times a third, that's 3. 3 plus 3, of course, is going to be 6. And over on this side here, this 3 I'm going to sub in, so 3 times negative 2, that's negative 6, plus 1 is negative 5. So this here is my final answer. After this, we're going to start right into our notes for inverse function. So what is an inverse function? It's basically switching around all your x's and y's. That's an inverse function. So if your original equation is y equals f of x, your inverse is now x equals f of y. In terms of an equation, here's what it's going to look like. If you had an equation that was y equals 5x minus 4, that's your original. Your inverse is now going to be x equals 5y minus 4. Another way that we can write this notation is using this y equals f of negative 1, x, and this negative 1 exponent is short for inverse. By the way, really quickly here, we never keep our equation like this here. We definitely want to rewrite this so that we get y by itself here. So the very first thing I'm going to do is just quickly rewrite this so that we have y by itself. So I'm going to go x plus 4 equals 5y. Dividing both sides by 5, we get y equals x plus 4 That's a 5. X plus 4 all divided by 5 there. And so this here is my inverse of this equation here, just an FYI. We're going to get right into the first question here of graphing. So what happens when we graph? So pretending that this is my f of x, I'm going to note this as f of x up top here. My inverse is going to be this graph here. This is my g of x. So what's really happening? So we are reflecting this parabola here across the y equals x line. So instead of having a vertical or a horizontal line to reflect it over, we're reflecting it over this y equals x line. So the first question we have here is what are the invariant points? So invariant points on this graph here has to be points on y equals x. So we have an invariant point right here. Sorry, that's kind of hard to see in black there. Let's pick a different color. We have an invariant point right here at 0, 0, because that's a coordinate that both graphs are passing through, and at 1, 1. Where do these lie? They always lie, so invariant points are always on your y equals x line, so on y equals x. Right down here, it says that for ordered pairs, it's really easy to figure out your inverse. All you have to do is quickly switch around all your x's and y's around. Okay, so ordered pairs wise, if you had 3, negative 3, 4, 0, 7, and 2, 9 respectively, our inverse for all of them will just be simply 4, negative 3. So we're just flipping around all the coordinates here. 7, comma 0, and of course 9 comma 2 for our coordinate. Here it says here to find an inverse, basically this is finding an inverse function given an equation. So you want to rewrite all your f of x as y's as needed. It's just a bit easier to picture in your head. Exchange all the x's and y's, so switch all the x's and y's around, solve for y, rewrite with the proper function notation for an inverse function. So on this first example here, we have f of x equals 3x plus 2. So the very first thing I'm going to do, sub in for a y value. So I have y equals 3x plus 2. Next up, I'm going to switch around my x's and y's. So now this is going to say x and y is going to go right there. Equal sign was there, our 3 here, and our plus 2 here. Now I want to solve for y. I don't want to leave this equation as is. I want to write out an equation that has y by itself. So first things first, I'm going to move this 2 to the other side. So I have x minus 2 equals 3, and let's keep that y there, 3y. And of course, to get y by itself there, I'm going to divide everything by 3. And yet the x minus 2 up top in your numerator. Here, this is our equation, and I want to finish this off by writing it in proper function notation. So this is f inverse of x equals x minus 2 all divided by 3. It says verify if verify it is an inverse. Yes, for sure, this is an inverse. Another way that we could verify that it's an inverse, not only based off of the equation, sub in a value for x and y. So let's pick the numbers of 0. So if x was 0 initially, so what's our y value initially? This is 3 times 0, which is 0 plus 2, so our y value should have been 2. I'm hoping that my inverse will get me to 2 comma 0. So if I had 2 subbed in here, I'm looking for a 0 for an answer. So if I had 2 minus 2, that's 0 up top, 0 divided by 3, still 0. So yes, that does check, and that our original and our inverse are actually truly inverse and original and inverse of each other. In this next example here, we're just going to work with a bit more complex equations. So it says here, find the inverse, check the work algebraically and graphically. Is the inverse of f of x a function? if not restrict the domain so that it is a function. And we'll talk about that once we start graphing it out. In this first example, so again, we're just going to repeat the same steps that we did in the previous example. So the very first thing I'm going to do, sub in a y instead of f of x. So I'm going to rewrite this as y equals 2 over 3 x plus 7. Second step, I'm going to switch around my x's and y's. So, I'm sorry, that's a y. So I'm going to switch around my x's and y's. I'm going to just do that in a different color here. So x now is equal to 2 over 3 y plus 7. So the first things first, I'm going to move this 7 to the same side as x. So I'm going to have x minus 7 equals 2 over 3y. Get rid of this denominator, get rid of this denominator 3 by multiplying everything by 3. So now that ends up with 3x minus 21 equals 2y. And to get rid of this 2 by dividing everything by 2, so we end up with y equals 3x minus 21. All of that's now divided by 2. And this here should be my inverse function, so I'm going to quickly rewrite it back in inverse, or in function notation, inverse. And there we have it. That's the first one done. To check our work algebraically or graphically, algebraically means sub in a number, graphically means use your graphing calculator. I'm just going to show you how to use your graphing calculator to check our first example here. So, going to my graphing calculator, I have a graph here that's blank. Everything should be standardized, so window of negative 10, 10, 1, negative 10, 10, 1. I have a y equals, I'm going to start typing in the original and my new equation. So original equation was 2/3 x plus 7. So the way I'm going to type 2/3 x is I'm going to use my fraction option. So that's alpha y equals in option 1. I type my 2/3 right here. Again, you could have just easily typed that in using your brackets, but I like this function a bit better on the TI-84s. I have x here, and it's going to be plus 7. That's my y1. In y2, I'm going to type in that new equation that I just built. And again, it's alpha y equals option 1 is my shortcut that I'm going to use. I have 3x, and that's going to be minus 21 up top in my numerator, all divided by 2 in my denominator. That's pretty much good. If I hit graph, let's see what happens once I hit graph here. I have two lines and they look like they're converging. Kind of hard to see that these are inverses of each other, but let's pick a coordinate and double check. If you picked on right here, this coordinate here looks about right on my original. This looks about 2, 4, 5, 6, 7. So this original coordinate here is 0, 7. On my inverse, it should be 7, 0. So let's double check. So this is 2, 4, 5, 6, 7. There you have it, the same coordinates, and they are just inverse of each other. If you want to take a look at other coordinates, simply go second graph on your calculator and it brings up a table of values. All you want to do now is compare the same ones. So if I was looking for, again, I was looking at 0, 7 originally. If I scroll down to 7 here, I'm hoping that in my new graph it was 7, 0, and there you have it, it's right there. I noticed here that on my new graph, I had 5, -3. So the inverse of that would be at -3. I'm looking for +5. So if I go all the way back up here, -3, I'm at +5. There you go. Graphically, we are inverses of each other on this graph here. So moving on, we're going to just start solving the rest of these questions here. And again, I'm going to start by subbing and doing a quick switch. So I sub in my y. And doing a quick switch around. So first things first, I want to get rid of this 8 at the end here. I'm going to move it to the same side as x. Up next, I'm going to get rid of this negative sign in front by dividing everything by -1 basically, so that switches all these signs around. So that's now negative x minus 8 equals up next, I got to get rid of this squared. The opposite of a squared is a square root, so I'm going to have plus minus square root of negative x minus 8. That's all equal to y plus 3. And finally, moving this 3 to the other side, I end up with y equals negative 3 plus minus, because there's a radical there, plus minus negative x minus 8. And there we go, we have our second equation done. And again, I should verify using my graphing calculator. You'll see it a bit easier using your graphing calculator. On this next one here, again, I'm going to start off by rewriting or doing my quick switch because it's already in y equals. So I'm going to just switch these around. So this is now going to be x equals y in my numerator, y plus 1 in my denominator. Here I got to get rid of that denominator, so I'm going to multiply this y plus 1 out of the denominator. That's going to get me xy plus x equals y left over. I want to isolate for y somehow, so I'm going to move this y on the right over and this x here away from it. So I have xy minus y equals negative x. Factor out an x, or sorry, factor out a y, because that's what we want to get. Factoring out a y, you have x minus 1 equals negative x. And of course, to get y by itself, simply divide off this x minus 1. And there we have it. That's going to be my inverse function. Let's quickly rewrite it. And again, to check my answer, I should use my graphing calculator to double check that this here truly is an inverse of here. And how do you do that? You're going to take a look at the actual coordinates and see that your coordinates have switched around. In this next section here, we're going to take a look at the domain and range for everything for all three of the same graphs that we had originally. So for this first one here, just an FYI, if I had graphed it, which I still have it on my graphing calculator, here's my line. There you go. It's just a straight line. So my domain and range for this first one here, my domain, and I'm going to use interval notation, so it's negative infinity to positive infinity and close bracket, and we're done. And we're using rounded brackets because we don't want to include infinity. The range to the lowest and highest it's going to go is from negative infinity all the way up to positive infinity. There we go. My inverse function, we did figure this out earlier. The inverse function here was this guy here, this equation of 2 in denominator, 3x minus 21 up numerator. And again, we already graphed this earlier. That's my line here. It's just a straight line again. So again, my domain and range for this one, domain and range of the inverse of domain, range. My domain is also negative infinity to positive infinity. And my range is from negative infinity to positive infinity as well. So there's no changes at all for a straight line. For the next two, I definitely want to graph it, so I'm just going to set up my graphing calculator and then show you. So here we go. I have typed in on my graphing calculator my next equation here. So again, this is the equation we're working with. My inverse function, and again, I'm just going to quickly jot down my inverse function. Inverse was that minus 3 plus minus the radical sign of negative x minus 8. And the way I type all that into my graphing calculator is as follows. Please take a look. So I have my y1 as my original function, and y2 and y3, there is no such thing as a plus minus button on your calculator, so I had to do one with a positive sign here and one with a negative sign or subtraction sign here, and that's going to cover off my basis for the plus minus. So you're going to see three pieces of graph kind of come at you. Once you're ready, hit graph, here we go. So there's my first one down here, and my two pieces are already off to the very far left here. Kind of hard to tell, but I guarantee you that if you had graphed this properly, these two pieces should have connected. So let's take a look at our domain. On the original function, it's a parabola going downwards. So my domain here, again, I'm going to use interval notation. My domain is going from everything left to right is negative infinity all the way up to positive infinity. My range, though, my range is going to be slightly different or slightly special. If I go back to this graph here, my range, the lowest I go, which is all the way down here, by the way, your graph continues going all the way down, is negative infinity. That goes all the way up to as low as, or basically as high as, it looks to be negative 8 right there. So my range is going to go from negative infinity all the way up to negative 8. Let's take a look at the domain range on our new function here, on our inverse function. So my domain here is as far left as possible. These lines are going to continue on forever, as far left as possible, and it goes as far right as, and this number here is negative 8. So my domain on my inverse is going to be from negative infinity to negative 8. My range, the lowest and highest it's going to go is the lowest it's going to go, and this line here, this black line is going to trace down. It's going to go down forever. This red line is going to trace upwards, and it's going to go in an upward trend forever. So that's negative infinity, positive infinity. And there we go. That's my new domain and range on my inverse function. For this last one here, again, I'm going to set up my graphing calculator, and then I will show you what I typed in. So for this last one here, this is what I'm typing in on my TI-84. So again, in y1, I have my original equation. My original equation was x divided by x plus 1, and so I have my x divided by x plus 1 here. My inverse function that we found earlier, and I will jot down right now, was negative x over x minus 1. So again, going back to my graphing calculator, TI-84 is what I'm using. I have both already typed in. I hit graph once I'm ready, and this is what they look like. So I have a blue line here, a blue line here, and that's part of the original. And here's the red and red. Reminder that there is your inverse line. Your inverse line is y equals x. That basically both of these graphs are going to reflect on. So this blue line here, this blue original function line, is going to reflect right on here. So that's what this red line here is. It's a reflection. Up here, this blue line is going to be reflected, and it's going to end up being this red line right there. So let's take a look at our domain and range on the original and then on the new. So domain, range. So on the original graph, let's take a look. So as far left, and again, domain and range is talking about left to right. As far left as we can go, we're going to infinity. But again, there's two pieces of graph here. So I'm going from negative infinity all the way up to whatever this number that our graph is trying to skip. This number here looks to be negative 1 that we're skipping. And then from negative 1 all the way up to positive infinity is how I would trace the rest of that graph out. So we have for a domain, and I'm going to use set notation in this case here, it's a bit easier. We have x cannot equal negative 1, but x is an element of a real. Our range on this graph here, the lowest we're going to go is negative infinity. We're going as high as, and if you take a look, it's just turning, and we're going to skip a number here, and that number so happens to be 1. On the other side of that, we're going to continue off from the other side of 1, going off to positive infinity. So our range, again, in set notation is is y cannot equal 1, positive 1, but y is an element of a real. In our inverse function, if you take a look at your graphing calculator, again, it's the same thing, left to right. Left, we're going to negative infinity all the way up to, and this number here that we're skipping looks to be positive 1, and we continue on the other side of positive 1 all the way up to infinity. So again, it's easier to do this one here because we have two pieces in set notation rather than interval notation. So again, curly bracket, we're skipping positive 1, so x cannot equal 1, but x is an element of the real. And our range is going to be, and we're skipping, y cannot equal negative 1, and y is an element of a real. And hopefully what you noticed here for domain and range is on my original domain and range, if my graph has an inverse, the domain and range just literally switch positions. So here in example 1, you really can't tell that there was a switch happening. In example 2, something did happen here. So my range and domain switch spots in my inverse compared to my original. And here, definitely on the last one, we switched spots for my domain and range. So what do you notice about the domain and range of the function and its inverse? Domain and range switch for the inverse. And sorry, I'm just going to type that out because I believe my typing will be much cleaner and much faster than when I try to write this out. I apologize, I'm just having some technical issues. There we go. Domain and range switch for the inverse function. All right. Moving on to example 4. So given the original function, sketch a graph of the inverse, list any invariant points. So all we're doing here is taking all these coordinates and we're just switching all their x's and y's around. That's all we're doing, is we switch all the x's and y's around. If you want to do it that way, you definitely can. The other way to do this is if you drew in a line right down your y equals x, and then flipped it along that, that would also work. And so I'm just going to quickly sketch that in, and you could reflect everything off of that line there, and that would be the same thing as well, and that would also work. So here we have, let's take a look at some of our coordinates. This looks to be 1, 2, 3, 4, 5, 5 and, sorry, negative 5 and 3. So I'm looking for 3 and negative 5 as a coordinate. The next one was negative 1, 2, 3, negative 3 and positive 5 here. So I'm looking for positive 5 and negative 3. My next coordinate here was negative 1 and negative 1. And so if I switch those coordinates around, that's an invariant pointer, by the way. It's on our y equals x line, so there's nothing to switch around. So I am just going to put a dot on that same dot. On this one here was 0, 2, so I'm looking for 2 and 0. And again, I end up with another invariant point right here because it's on our y equals x line. So I'm going to put a coordinate there at 1, 1. And last but not least, we got 4, 2. So I'm looking for 2, positive 4. And all I do now is I'm going to try my best to connect my lines. Let's do it in a different color so that we can kind of see. So And there we have it. That's our new inverse function. And it says here, let's list off any invariant points that we had. We definitely have two invariant points. And our two invariant points are going to be at 1 comma 1, and in this case here also -1 comma -1. So we had two invariant points there. So again, it's this guy here and this one down here. It says here horizontal line test can be used to determine if the graph of an inverse relation will be a function. If the horizontal line intersects the graph of the original more than once, the inverse will not be a function. So you want to use a horizontal line test prior to graphing out your new inverse function. So horizontal line test is basically saying take a line, go left to right, that's horizontal, and then go from bottom up or top down, however you want to move it. And as long as this line only touches the graph in one spot, touches your original graph in one spot ever, then yes, your inverse will also be a function. But if it touches your original graph in more than one spot, it is not a function. And so literally, if I stop this line right here, I touch my original graph in two spots. So that means my new inverse function is not an actual function. So, and I can use the vertical line test on the new inverse to double check that as well. So if I did a vertical line test on the new graph, I can definitely show you that, yes, I crossed my inverse function or inverse graph twice. That makes it not a function. Here in example 5, all we're doing is graphing a parabola and finding the inverse for it as well. So here we go. So I just graphed the original, and I'm going to try my best to hit as many of our dots as possible. I am struggling on drawing right now. That side's a bit better. And then so now all I'm going to do is take all my coordinates, flip them around, like switch all the x's and y's around, and graph my new one, and we should be done. So at 0, 0, still at 0, 0. We have 1, 1 still there. 1, -1 is going to be right here. This one was 2, 4, so I'm looking for 4, 2. So 4 and 2 is right here, and here was -2, 4. So again, I'm looking for 4, -2. It's going to be right down here. And again, our function is going to be a sideways looking U. And there we go, trying my best to hit as many of these dots as possible. I apologize, this isn't going to be as clean as I hoped. And there we go, we're done. And again, if you had to figure out your inverses would have been on that y equals x line. So at 0, 0 and at 1, 1. Here, by the way, we also have graphed the inverse function of g of x equals x squared, which we have done. That's my inverse function. And there's this extra little piece here. This x has to be less than 0 piece. For x has to be less than 0, that's going to be a restriction. So really, that means out of my graph, if this is my x squared, the only piece that it really wanted me to graph was everything less than 0. So this piece right here was what I needed to graph, but I graphed too much and I graphed the whole thing. So here, if this was my piece that I wanted to graph only, if I reflected it on my y equals x line, it's going to be this piece down here in red. So that means that these two pieces here, I'm going to circle them, actually should not have been graphed, and they don't exist based on this restriction. But for me, I find it easier to graph everything in full and then erase everything that you don't need. So I would have erased off these two pieces because I wouldn't really need them. Here, this is just transformations for an inverse summed up in a nutshell. So what do we have? Again, what are we doing? if you had coordinates, you're just switching around your x's and y's. In this case here, it's saying if you had coordinates a, b, your inverse will have coordinates b and a. If you had an inverse and you had a shift, it still would be that shift is still on x, that horizontal shift, so you're shifting it 1 to the right, so it's still going to be +1, but you would have had to do it on the inverse. And again here, if you had a reflection, a vertical stretch on the inverse function, and you had a horizontal stretch, well, horizontal is only on the x value, so there we go, we have the 1 over 3 times b, which is b over 3, and this -2 is a reflection and a vertical stretch that's only on your y values, which after the fact you would have had to switch and then put it on a. So just an FYI, here's just a few examples that you want to memorize, and not memorize, but kind of know and work through. If you have any questions, that's the end of today. If you have any questions, please feel free and ask.